Hi, everyone. Thank you so much for joining us this evening for another Wild Wednesday. This week's presentation is on Oregon's Vanishing Glaciers, and it's a presentation that I personally am super excited about, so I'm glad that y'all could be here to join us. My name is Jamie. I work for Oregon Wild in our Bend field office. For those of you who don't know Oregon Wild, we're a statewide conservation organization that's dedicated to protecting and restoring Oregon's wildlands, wildlife, and waters for Oregonians. As you know, the loss of our glaciers is directly related to climate change, and personally, I'm really honored to be working for an organization that's working to be part of the solution, at least from one small angle. We feel that one of the single biggest steps Oregon can take to combat climate change is modernizing our forest management laws. And if we do that alongside protecting really important public forests, Oregon can be an invaluable asset to mitigating and adapting to climate change. If you want to learn more about that, you can check us out on OregonWild.org. For a brief roadmap of what's to come this evening, I'm very excited to be joined by two really wonderful people who are involved with the founding of the Oregon Glaciers Institute. They'll give a 40-minute presentation followed by some questions and answers. If you have questions for Anders or Aaron, you can enter them in the if you see on the right-hand side of your screen, there's a little question inside of a speech bubble or a thought bubble. Just click that and put your question there. That'll come to me, and I'll pitch those to Anders and Aaron for as long as we have time at the end of the hour. And this is going to be recorded, so if you want to share it with friends or family tomorrow, you'll get it in your email, and we'll post it on our website, OregonWild.org, and it'll also be posted on the Oregon Glaciers Institute website. If your screen freezes for some reason or you lose access to the presenter's slides, just completely close out of the program and go back to your email, click that same link, and then rejoin this call using the same link that was emailed to you about an hour ago. And if you bought a raffle ticket, we appreciate your support. Thanks for helping make this presentation and other presentations like it a reality. We're going to be announcing the winners tomorrow, so we can make sure to get everybody who bought raffle tickets right beforehand. So look out for your email tomorrow if you were a winner for the book and a couple other prizes. And then next week is going to be our final Wild Wednesday for the year, because we're coming into holiday season. Next week's going to be a presentation on snowshoeing, and I believe it's Snowshoeing Central Oregon. So look on OregonWild.org for that if you're interested in learning more. And without further ado, I'm going to go ahead and turn it over to Anders. And Anders, I'm going to make you the presenter so you can share your screen.
Okay.
And it should be there for you.
All right, show my screen. Cool. All right, thank you everyone for having us. My name is Anders Carlson, and along with my colleague Aaron Hartz, we founded the Oregon Glaciers Institute this past May to look at and study Oregon's glaciers and try to address their change and how we can project the future of these glaciers and work towards trying to save them. Our talk today is going to be about Oregon's Vanishing Glaciers, and this is fieldwork we conducted this past summer. And just to drive right into it, what we were trying to do was get a census of Oregon's glaciers. Oregon is blessed with having 36 named glaciers, so official glaciers. These would be ones you can find in the federal government's directory of geographic names, of which these 35 of these glaciers here exist. White dot is each one of these is a glacier, exists in the high Cascades, going from Mount Thielsen in the south up to Mount Hood in the north. And then over here in the west, there's one official glacier in Benson, in the Wallowas, Benson Glacier. Now, these glaciers were named and recognized and mapped in the 1950s when the U.S. Geological Survey began making its topographic map series. And the thing that occurred here in Oregon versus other states is these maps have never been updated. The photographs that were used to map out the ice extents in Oregon were taken in the 1950s, and they've never been redone. So a lot has happened since the 1950s. And in this talk, what Aaron and I will be using as a backdrop slides will be photos of Oregon's glaciers that we took this past summer. And we're using these to build a database of presence of ice or lack of ice and throughout this talk. And so this is a picture here from the west side of Mount Hood showing Sandy Glacier and Reed Glacier. And these are still active glaciers, and they're still active glaciers and doing okay. relative to some of the other glaciers in Oregon. Anyways, a lot has happened since the 1950s. For instance, it's gotten warmer and drier. So these showing here on the right-hand side is a graph going from 1950 to 2020, and this is showing you the change in snowpack on April 1, so the end of the winter, and then also temperatures. And the snowpack data comes from snow courses, so physical measurements made into these white dots here in the Cascades, and then also 2 over here in the Wallowas. And so the blue is the average of the Cascade Mountain snowpack, and it's changed relative to the mid 2000s. And red then is the same for the Wallowa Mountains. What we see is that since 1955, there's been a decline in the Oregon snowpack in the Cascades of about 1.6 centimeter per decade. And the units on this is called snow water equivalent. So this is when you take your snow and you melt it and how much water is actually in the snow. So it's, you know, you have a really fluffy, light powder, and that gives you, you know, feet of snow. But in reality, since it's so light and fluffy, it's only 3 centimeters of water. And so it's a way to account for different snow densities. In contrast, the Wallowas have their snowpack has been declining as well, and that's about 0.8 centimeters per decade. So we've been getting drier, less snowpack at the end of this winter. Then on top of that, the white dots also have temperature records, and the orange ones here are also temperature records that don't have snowpack data going back to the 1950s. When you take these and average these together for the region, they show a consistent trend where blue is the Cascades and red is the Wallowas, where in the summertime, so June, July, and August, and also the mean annual temperature have both been warming since 1990 when these weather stations first began to consistently work and not have major gaps in their data coverage. What that means is that since 1990, both the Wallowas and the Cascades in the summer and an overall temperature over the year have been warming at about 0.7 to 0.8 degrees centigrade per decade, or 1.5 degrees Fahrenheit per decade. So the summers are getting warmer, and just the overall temperatures are getting warmer in these mountains. So warmer temperatures with drier winters is not good for a glacier. So that's leading us to, this was motivating then behind our summer field work was 70 years ago, Oregon had 36 named glaciers, and how many of those remain today? So this has not been conducted since, the census of Oregon's glaciers has not been conducted since the 50s. And then the backdrop here, this is on the east side of North Sister, and this is the former location of Thayer Glacier. And this was taken in early August, and by later in the year, there was actually no snow here at all. So Thayer Glacier is completely gone on the east side of North Sister. So before we get to what to do that census, we should first kind of define what a glacier is. And a glacier, in a physics kind of standpoint, going back to a physics class in high school or college, is a glacier is an ice mass that flows under its own weight. So the ice has to be at least 100 feet thick, and at that point, there's enough pressure on the bottom ice that it starts to deform, and so it's no longer a brittle substance, it becomes a deformable substance, and starts to flow like silly putty or toothpaste. Another way to think about a glacier is that it's a physical manifestation of climate on the landscape. So to have that ice be there, to be 100 feet thick, you first have to build up that ice, and for that to occur, you have to have snow last year-round. So the snow can slowly build up over time and turn from snow into ice through the pressure of the ever thicker snowpack. And then on top of that, the ice then has to reach up to 100 feet thick to then start to deform. So that means in the upper reaches of a glacier, there's snow year-round at that location. Once it's thick enough to flow, it then flows downhill under the force of gravity to down to a lower elevation where it's then warm enough to melt, eventually melt all the ice away. And that's where the glacier ends. It's actually warm enough at that point to melt all ice away. And so the terminus of the glacier reflects when it's hot enough to get rid of all the ice. So that's that physical manifestation of climate. So the upper parts of the glacier are the accumulation zone where it gains mass and snow can last year-round. And the lower part is the ablation zone, where the glacier loses mass, and it can lose mass by, in Oregon, it's mainly by melting, so just turning from ice into water. It can also calve off icebergs, so break off bits of ice into lakes. It's another way the glacier can lose mass, and that can occur in some places here in Oregon. And on top of that, what's always going on is sublimation, which is a small component of the ice loss, but that's the direct conversion of ice into water vapor. This is the same thing happens when you go to your refrigerator, your freezer, and you try to take out some ice cubes to make a drink, and the ice cubes are all gone, and that's because the ice cubes have sublimated away in your freezer, and they just turn from ice into water vapor. Now, in between these two zones of accumulation and ablation is what's called the equilibrium line. And that's called the equilibrium line because that's above it, the glacier gains mass, so it's positive, and below it, it's negative. But right at that line, it is equal. And that line is then the end of summer snow line on that glacier or in that region. And that line also then corresponds with it happens to correspond with the mean annual temperature being 0 degrees Celsius or 32 degrees Fahrenheit. That's the freezing elevation on average over the whole year. So that's, again, that climatic expression on the landscape. What causes a glacier to die then is this equilibrium line. It warms, and that equilibrium line rises in elevation, and eventually it's above the top of the glacier, and it can no longer accumulate mass. It's too warm for the snow to stick around year round in that region, and the glacier is no longer being fed. Eventually, it's just melting and losing mass every year, and eventually it gets thin enough to where it's no longer deforming, and then it's no longer a glacier. So that's how a glacier dies, is that equilibrium line rises above it. So let's look through some photos here of what that kind of cartoon was showing. So this is Crook Glacier on the south side of Broken Top. And here's my colleague Aaron for scale. Here is, this is late August. You can see the snow line here. This is last winter's snow, so 2019-20 snow year. And this was in late August. This would have been the equilibrium line at that moment. Below it here, these are earlier years of snow, and then here's the bare ice. If it snowed the next day, this would have been the equilibrium line for that whole seasonal year of the glacier, but it didn't. We didn't get our first snowfall till early October, and it probably means that the Crook Glacier didn't accumulate any mass this year. This is Villard Glacier on the north side of North Sister. It's still an active glacier as well. That kind of shows this process of taking snow from the accumulation zone down to the ablation zone. So here's the snow line again. This is early September. And you'll see these bands going across the glacier here. Those are annual layers of snow that have then turned into ice. And that dark layer is from the summertime when we have forest fires and there's ash and dust in the air, and also it's just dusty in Oregon in general in the summer. And that falls in on that winter snow and makes a dark layer on top of it that then turns into these annual bands. And so you can see this annual banding kind of going down, and that's that snow turning into ice and then flowing down to lower elevations, where here it's now hot enough that all the ice that can flow down here is then melted away at the terminus every summer. A little better image of that flow is from Hayden Glacier on the east side of Middle Sister. And over here is Diller too. So Diller and Hayden are still both active glaciers. And you can see up here in the accumulation zone, it's accumulating mass, and then there's these loopy bands going down here. That's those annual layers flowing along like toothpaste being spread across a table or something like that when your toothbrush. And so that's showing this ice flow down towards the terminus here, where it's then melting all away. So another photo here of that. This is Elliott Glacier on the northeast side of Hood, and Langle here over there. This is in early August, and you can see there's not much exposed ice yet as the snow has been melting away. Then to start exposing ice, and the snow line then creeps up in elevation through the summer. But again, ice flowing down in elevation. In this case here, there's a large moraine that was deposited, and a moraine is a buildup of debris that's been eroded by the ice at its base from the deformation, so scraping along the bedrock, or from rockfall. As you can see up here, there's a lot of rockfall coming. This dirty kind of here is a dust coming from actually a recent rockfall event onto the surface. And that rock comes down to the terminus, and when the ice melts all the way, still got those rocks, but there's nothing to carry the rocks, and they build up into a moraine. And here's my dog for scale. So a moraine shows you the former limit of a glacier when it sat there for a while. Another one here, this is Coe Glacier on the north side of Hood, and Aaron took this photo in May, and you can see that again, here's the snow line beginning to creep up through the summer. And again, this up here is the accumulation zone, where eventually, even at the end of the summer, there'd still be some snow up here that turns into ice that eventually can flow down to the terminus where it melts away. And here's that moraine that the Coe Glacier sat at for much of the 1800s, and has been retreating from ever since the early 1900s. So I'm going to switch over now to Aaron. He's going to talk to you a little about why glaciers are important, some other features of our field work. And just behind here is Prouty Glacier on the east side of South Sister. And just again here, this glacier is still an active glacier, but it's an example here where this is from early September, and you can see the snow line here is creeping up above the top of the glacier. So the example here, Prouty probably isn't gaining any mass anymore. It's only losing mass, and that makes it not in good shape. And so while it's still an active glacier now, it's not going to be one in the near future. So Aaron?
All right, thanks, Saunders. So I think glaciers are important for many reasons, but I just want to outline a couple of those right now. And it's really important to remember that glaciers are a water resource. You know, glaciers are water locked up in frozen form. In the mountains, after the seasonal snowpack has melted away, it's the glaciers that are feeding mountain streams. That's important for a variety of reasons. Glacier meltwater flows into watersheds that can be used by municipal water facilities. So one example of that is the Crook Glacier in the crater on Broken Top. When that melts, part of that water flows into a man-made canal that makes its way into the Tumalo Creek watershed, and that's where the city of Bend gets its drinking water. Much of the water that melts off of the west side of the Three Sisters ends up going into the Willamette River, and that's important for municipal water from Eugene to Corvallis, Salem, and Portland, and all the cities in the Willamette Valley. So, you know, when we're done with the snow for the season, it's the glaciers that are really feeding the mountain streams and giving us that water. And in addition to people using that water, it's also important for agriculture. So
There you go. Yeah, there you go.
Anders is changing all the slides. So that water is also useful for farmers and ranchers. You know, the water is important for livestock and watering crops. And that's especially important on the east side of the Cascades, where we live in such a dry environment. So that water resource it's crucial for farmers and ranchers to continue doing what they're doing, not only in Oregon, but all around the American West. It's also important for habitat. So, you know, when we have glaciers melting in the summer, that water flows into streams, and that's important for fish habitat. Many of the fish species in Oregon and really all around the world depend on cold water. That allows them to have more oxygen in the water. So by cold, cool water melting out of the glaciers, that allows for good fish habitat. And there's also many different species of wild animals living in the mountains that depend on that water also. That picture on the left is my dog. It's not exactly a wild animal, but it gets the point across. So fish habitat and animal habitat, you know, it's hard to really state how important this water coming out of the glaciers is for those animals living in the mountains. And on top of that, you know, it's also important for people. Glaciers are an integral part of the recreation experience in the mountains. So mountaineering is a very popular activity in the Northwest, and glacier mountaineering is the quintessential mountaineering experience in the Cascades. And it's important for people to go out and experience nature and see these wonderful places and have that recreation experience. And, you know, that's one thing that sets the Cascade mountain range apart from other mountains in the West, is that we have these glaciers and that people can go up there and enjoy these special places. So recreation is important, but there's also an impact on the economy. You know, people travel from all over to have fun in the mountains in Oregon. And in the case of Mount Hood, people travel worldwide to come and climb Mount Hood. And when people come to the mountains in Oregon to recreate and to climb and to ski tour and things like that, it has a big impact on the local economy. Everybody who's going mountaineering has a backpack, an ice axe, boots, clothes, and things like that. And oftentimes they buy those items at local gear shops or regional gear shops. People stay at hotels like Timberline Lodge and the hotels in Bend. And of course, there's nothing better than after a day of mountaineering or ski touring, going into the local breweries and telling stories about your day up in the mountains. So, you know, the recreation is important for people to have that experience, but it really does have a big impact on the Oregon economy as well. And with that, you know, it really is a part of our identity in the Northwest. You know, from Seattle, people can see the glaciated peak of Mount Rainier. From Portland, people see the west side of Mount Hood, and that's the top picture here. That's the iconic view from the Portland skyline looking out to Mount Hood. And even the organization called Visit Bend has a glaciated peak front and center on their website. That's South Sister down on the bottom here in Central Oregon, which is one of our glaciated peaks. So, you know, we see these mountains quite often. I think a lot of people don't realize that there are glaciers in the mountains. But, you know, these peaks with the shimmering white glaciers are a part of our identity here in the Northwest. And glaciers are also important because they're a record of climate change. We don't always have meteorological recordings in the mountains, especially here in Oregon. Our high alpine environments and the glaciers are in designated wilderness, so we don't have automated meteorological stations up there, but we can look to glaciers as, in a sense, a record of climate change. People recognize this, and worldwide there are many groups studying glaciers, and they measure glacier length, glacier surface area, glacier thickness, and things like that. And over time, you can use this long-term data set to understand how glaciers are changing with a changing climate. Up in the upper left, you see that little blue box, that's Oregon. So that's showing us that we don't have long-term monitoring data sets here in Oregon of glacier change. That's something that Anders and I are hoping to you know, contribute to with our program here, but we just don't have that record of glacier change in Oregon. There have been intermittent studies on specific glaciers from researchers at the universities in Oregon and elsewhere, but nothing long-term and consistent. So that's one of the reasons why we founded the Oregon Glaciers Institute and why we want to create an ongoing long-term monitoring program. So we started this year by trying to figure out how we could utilize our time the best to start learning about Oregon's glaciers. And what we did was we decided that we wanted to start by figuring out which glaciers in Oregon are still active, the glaciers that are still moving and flowing and deforming on the mountain landscape, and which glaciers are no longer active, or maybe just some dead ice patches. So we set out this year to get an updated count of which glaciers are still active and which glaciers are no longer active. And we did that by looking back in time. So Anders mentioned that when the US Geological Survey mapped the glaciers in Oregon, they used aerial photographs from the 1950s. And that's what you see when you look at a USGS topo map. You see the area of the glacier that existed 70 decades ago. And those maps haven't been updated for the glaciers. So we took these maps and we used some GIS software. And in this picture, that's the Bend Glacier on Broken Top here in Central Oregon. And we were able to make outlines of the glaciers. And with this software, we can use that to calculate surface area of what was originally mapped for the glaciers. Next, we looked at recent satellite imagery. So now we see the Bend Glacier with the red outline of what was originally mapped. And then you see this small patch of ice in the middle. That's the current extent of the glacier. So we started looking at how these were changing in terms of surface area. We could also calculate the surface area, or approximately, of what we see in these satellite images, and start to get a look at how the area of ice has changed over the last 70 years. And Anders mentioned, I think before, that a glacier really needs to be about 30 meters thick or 100 feet thick of ice to be active and flowing and deforming. And we were able to use this software to calculate surface area and correlate that to a depth. So we found a data set that correlates surface area to glacier thickness, and we were able to identify which glaciers were kind of on the cusp of that 30-meter thickness. We came up with that being about 0.1 squared kilometers of surface area. That's approximately 16 football fields in area. And we got that area with the software, and we identified these glaciers with about 0.1 square kilometer of area as being at-risk glaciers. So they're on the cusp of potentially being active or non-active. After we made that initial analysis using the maps and the satellite imagery, we wanted to go out into the field and get eyes on these glaciers and look at some visual clues to determine if they were active or not. In total, we visited about 20 glaciers this summer. So we didn't visit all the glaciers in Oregon. We focused on the glaciers that we deemed at risk that may or may not still be active glaciers. So here's the Bend Glacier on Broken Top. And one of the criteria that we looked for was if there are crevasses in the glacier. So as the ice moves and flows, it pulls apart and cracks. Those are the crevasses in the glacier that indicates that the glacier is moving. And so that was one thing that we looked for as a clue to determine if this glacier was still active or stagnant. Glaciers that are no longer moving or just dead ice bodies will not have crevasses forming. In addition to crevasses, we looked for the presence of what we call glacial flour. And the flour is just really fine sediment in the meltwater coming out of glaciers. As a glacier moves, it erodes the bed surface below it, the actual rock and substrate below the glacier. And as it moves over that bed surface, it grinds up the material, and you see this very fine sediment in the meltwater streams. It looks sometimes kind of milky, like milky water or dirty water. And we were able to use that as a clue if the glacier was moving or not moving. This is the Carver Glacier on South Sister. In addition to that, we looked for other clues, such as if the terminus of the glacier was convex, or if it was a really thin sheet coming down out of a concave shape. So if the glacier is still moving, we see this nice convex shape at the terminus, and that was one of the criteria we looked for also. This is the Lewis Glacier on South Sister. We also, when we were examining these glaciers, we also looked to see if there was snow in the accumulation. If there was not, that was giving us an idea if maybe the glacier had some accumulation for the year, or if it was not going to see any accumulation at all. So in all of the glaciers we visited, we made notes, took pictures, made some GPS measurements to refine our surface area analysis, and this is what we spent a lot of our summer doing, going out to these glaciers and visiting this. So I think Anders is going to take it from this point on again.
Okay, thanks, Aaron. Yeah, so let's go through now a census kind of field trip through Oregon's glaciers here. And we'll start off with down at Mount Thielsen and also in the Wallowas here, so the outliers. And this is taking the 36, this is a table here of the 36 named glaciers in Oregon, with Mount Hood up here in the north, down to Mount Thielsen in the south of the Cascades, and then the Wallowas here in the east. We'll start off over in the Wallowas first. And Benson Glacier in the Wallowas is no more. So this is Eagle Cap here. There is a smearing of ice left of what is the former glacier of Benson. It used to flow all the way down almost here to this lake. You can see this moraine here that was deposited before. So there's some dead ice, stagnant ice left, but it's too thin to deform. So Benson Glacier is no longer an active glacier. While poking around the Wallowas, though, it turned out that while there's one named glacier in the Wallowas, there probably was a fair number of glaciers there back in the 1950s. Just on the other side of Eagle Cap, there is another smear of ice that's left here, and that we're just calling North Benson Glacier with a lowercase g, since it's not an officially recognized glacier. But that is also, there's some ice left, but it is no longer moving and it's stagnant, and so it's a dead glacier as well. And when you start picking around those high peaks of the Wallowas, you find a fair number of glaciers. So this is Sacagawea Peak here, And it had a glacier here that is now, this is just some snowpack there, but you can see there's a moraine, there's a little lake there. And so there was a glacier in this region here back in, at least in the 50s, and it is no more there, but it wasn't ever named. And this glacier here would have been bigger than the named glacier, Benson Glacier. Same is true on the Matterhorn. Again, another moraine here that deposited ice, and this is filled with snow. Again, the Matterhorn, the Matterhorn Glacier in lowercase g is gone as well. So these are two examples of the unnamed glaciers that were in the Wallowas that aren't there anymore. Going down to Mount Carlson here in Southern Oregon, there's Lathrop Glacier. This was the last glacier identified in Oregon and named, and this happened in the 1960s. So here's an aerial photograph from 1965, and you can see in this, there are these two chutes on the north side of Lathrop, and this is the eastern chute where there's some ice in there, and there's crevasses flowing down, and same thing on the west. It's coming down, and this is where the terminus is, depositing this weirdly shaped moraine. So we were there on July 31, and that western chute has bare bedrock in it, and that eastern chute, Aaron poked around in this with his ice axe, and this is just snow. There's no ice left in that. So Lathrop Glacier was the last glacier named in Oregon, and this summer was the first one we determined was no more. So the last shall be first in this case. So if we come back to our official Glaciers of Oregon table, we can cross off Benson as being alive anymore, being a glacier anymore, and we can also cross off Lathrop. We can also start though an unofficial Glaciers of Oregon table, and we found 8 glaciers in the Wallowas, of which 7 were not named or recognized on maps. There's in the maps you'll see a snow or ice body there, but it's not called a glacier or given a name. So there's a total of 8 glaciers we can find that disappeared in the Wallowas over the last 70 years. So we can move now up here from Carlson up to the Three Sisters region, and we'll first go to Broken Top. And Aaron and I have already shown you Crook Glacier here, which is still an active glacier, and Bend Glacier, which is not looking good in that photo Aaron showed, but it's still an active glacier. One that is an unnamed glacier that probably many people have walked by is what's called unofficially No Name Lake, and that should be a lowercase L there, on the east side of Broken Top. And this here has been called East Bend Glacier by the USGS, but as an unofficially named glacier. And so here, that one is dead as well. There's a smearing of ice left up there, but it's not moving or deforming. You'll see there's no snow line, snow on it. So the snow line in this case is above East Bend Glacier. And so this is just some stagnant ice left melting on the landscape. On the west, I won't show a photo here, but on the west side of Bend Glacier here, there's another glacier that was there. And you can see this snow patch here. That's all gone now, and there's just bare bedrock. But there was another glacier on Broken Top too, back in at least in the 1950s. So if we come back to the table here, we can put Crook Glacier and Bend Glacier still being there on Broken Top. I put an asterisk so by Bend to show that it's not looking good and is very unhealthy. And on the unofficial list, you can put in West Bend and East Bend Glaciers as also being gone. Moving to South Sister, this is Clark Glacier here on the south side of South Sister. We held a funeral for this glacier in mid-October, and that was to try to raise awareness about this glacier loss occurring in Oregon. And this is what's left of Clark Glacier. Here's the ice extent in the 1950s, and people hike by it when they climb up South Sister from the south side here, and they walk by Lewis Glacier that Aaron just showed a photo of. And there's a dog down here, Aaron's dog here for scale. And so this is not a very large patch of ice. It's very thin. That's what's left of Clark Glacier. We looked at Carver Glacier and its glacial flower here, and that's where that photo's from right down here at its terminus. Now, Carver Glacier on the map, though, is really 3 glaciers. It was probably, prior to the 1950s, was 1 glacier, but by the time they mapped it in the 50s, it had broken up into 3 glaciers, of which they were only given 1 name. So this is the central part of Carver Glacier, which is right here, and that's still an active glacier, but you'll see there's an ice body at a higher elevation above it, and it deposited a moraine. You can see this moraine above Carver Glacier, and inside there, there's now just stagnant ice. So we called this one South Carver Glacier, and it is a dead glacier. And then to the north of this photo here proper, there's another part of Carver that goes down to lower elevation that is just bare bedrock now. And so we call that one North Carver Glacier, unofficially with a lowercase g, and that then is also gone. And the same, if we move here a little bit to the west, is true with Skinner Glacier. So Skinner was probably a much larger glacier prior to the 1950s and was breaking up into 3 glaciers when it was mapped by the USGS. And now in this case, the middle portion of the glacier here, the middle body in this location right there, and then the lower portion here are still active ice bodies. So they're still active glaciers. So there's Skinner Glacier. We call this one North Skinner. And then higher elevation component here, this is that snow patch there, that's gone. So South Skinner Glacier, as we call it, is no more. So Skinner Glacier is really 3 glaciers, of which 2 still remain. Now here's what is interesting here, above Skinner Glacier towards the summit on the map, and so this is a digital elevation model with the ice extents of from the USGS topographic maps projected onto it. There's this open area here going up in elevation where if you look at Lost Creek Glacier here, which is still an active glacier, that goes up towards the summit, why isn't there any ice up here and the map? And it turns out there is. And we found a new to at least humanity glacier. It's been there for a couple centuries at the bare minimum on the north side of South Sister. And we unofficially named it Ruspin Glacier. And so you can see here, there's a snow here on it. There's some bare ice down here and some crevasses. The terminus is covered in debris and rockfall. So this is probably why it was missed. It's on the north side of the mountain, so it's always in the shadows, and so you won't see it on an air photo. And on top of that, it has a fair amount of debris covering its end there, so if you're not looking for it, you won't see it. It's camouflaged. But there's another, so in this here on the zoomed in portion of this topographic map, there's actually a glacier sitting in this bowl here that is not on the map. So in addition to saying some glaciers are dead, we found a new glacier this summer as well, which is kind of cool. And if you move then a little bit further here to the west, you'll see Eugene Glacier there. That's right here on this map there. That is also, we're considering a dead glacier. It's relatively recently passed away. There's still some snow here, but it's just a little bit of ice left. It's got a concave terminus, and it's just a smearing on the landscape there. So Eugene Glacier is no more. Now, we already showed you, I won't show a photo here of Lost Creek, but that is still an active glacier on the west side of South Sister. And we saw photos of Lewis and Prouty, with Prouty not looking too good these days. So if we come back to our official glaciers list, we can cross off Clark, and we can cross off Eugene on South Sister. And if we go to our unofficial list, we can cross off a couple more that weren't officially named. And then we have to add a glacier on that is still there, that was hasn't been recognized before, Ruspin Glacier at the bottom there. So we can move now to north and middle and north sister here. And then on the south side of Middle Sister is Irving Glacier, and Irving Glacier is really 2 glaciers. So Irving Glacier proper here is a stagnant dead ice body here. You can see it's got a concave terminus. It is no longer deforming. And just to the south of that is this other ice body called South Irving Glacier that is also stagnant ice body. And you see these cracks here are not crevasses from ice movement, rather this lake here in front of the glacier, the stagnant ice body is melting back underneath the ice, and this is the ice just collapsing into this ice tunnel, ice cavern. Just to the southeast of Irving and South Irving Glacier are 2 other ones that were never named, but deposited moraines on the landscape, and in the 1950s had a permanent snow or ice body mapped by the USGS there. So this one here is by Camp Lake, in between Middle and North Sister, and it's just a snow patch now, but there's a little moraine running here. And then by Chambers Lake, there's a bigger moraine deposited here, and you can see there's still a bit of stagnant ice left, but that is also no more. So we unofficially calling these Camp and Chambers glaciers that are now dead or completely gone in the case of Camp. On the west side of Middle Sister, we have Renfrew Glacier. And this is still an active glacier, but it's probably nearing the end of being active. It's a fair amount of ice left, but it's breaking up as it's been thinning down over the years into different separate ice bodies that eventually become too thin to deform. And you can see, like this case here, this portion is becoming concave. There's a bit of convexness over here. So it's nearing the end of being a glacier proper. But as of right now, it still is an active glacier. Okay, yeah. We also showed already photos of Diller and Hayden, which are active glaciers, and Collier Glacier. I know we're not showing a photo right now, but that is a large glacier that still is active. And we showed photos of Villard and Lynn Glacier are both still active glaciers. With Lynn, it doesn't look too good anymore. It might be nearing its end of its lifespan. Thayer Glacier is completely gone. But in between Villard and Lynn, there's another ice body here that deposited a moraine. And you can see this moraine right here, and there is no more ice there. It's just bare bedrock. So we're calling this crack glacier, and it's gone. And here, right over this ridge is where Lynn Glacier used to be. The last bit of ice in that one photo that Aaron showed is right up in over here around this corner that's hanging on. It still shows crevasses, and so it's still technically deforming. So we come back to this table here. On Middle Sister, we can cross off Irving. On North Sister, we can cross off Thayer. And then we go to our unofficial list. We got a couple more we can cross off there as well. Let's move up towards Mount Jefferson, but on the way we have to stop at Three Fingered Jack because Jack Glacier used to be there. Now this is an unofficial glacier, but it's probably one of the most known unofficial glaciers in Oregon because people have hiked by it forever on its moraine. And there are photos from the 1980s showing an ice body in here with crevasses calving icebergs off into this lake. So after the 1980s, Jack Glacier ceased to exist, but it was never mapped by the USGS, and they never even put a snow or ice body in this region here behind this moraine. But there definitely was still a glacier there in the 80s. Moving to Jefferson, we did not go into field on Jefferson because we could conduct the field work we wanted to just from satellite imagery. So on the left here is the USGS topographic map for Mount Jefferson. And on the right is a satellite image from October 10th of this year, so right before the first snowfall occurred, which happened on October 11th. And you can see Russell Glacier and Jefferson Park Glacier are still ice bodies. Whitewater Glacier is still quite large here on the east side. Waldo Glacier on the south is nearing, it isn't looking too good, but there's still some evidence of crevassing and ice movement. Glaciers that disappeared here are Milk Creek on the west side. There's this bare bedrock here where there was an ice body here in the 50s. And then Timberline Glacier, on earlier maps made by the US government prior to the 50s, Timberline Glacier is a named glacier. It was not named on the USGS topographic map, so in the 50s, but there still is a snow or ice body here, and that is completely gone from the landscape there now. So on Jefferson, we can cross off Milk Creek Glacier, and then we go to our unofficial. We got to expand it to put in Three Fingered Jack and cross off Jack, and then also cross off Timberline. Lastly, we'll come up to Mount Hood here in the north. And the glacier that's most obviously disappeared on Mount Hood is Palmer Glacier. Now, Palmer Glacier has also been called Palmer Snowfield, and the term snowfield is inaccurate because in 1981, the USGS made measurements of Palmer's thickness, and there was at least 150 feet of ice in Palmer Glacier at that time in 1981. And so it was still an active glacier in the early 80s. And this is what it looked like on October 7th of this year. There's just some snow patches left. Coleman Glacier above Palmer up near the summit of Mount Hood is still an active glacier there. And White River here down on just to the east of Palmer is still an active glacier in White River Canyon. We can move a bit to the west over here to Zigzag Glacier. And this one we thought was a dead glacier just by the fact that Palmer is basically gone. There's only snow there because of Timberline Lodge helping maintaining summer snow operations there for there's ski and snowboarding camps. But it turns out Zigzag Glacier is still active, but it's been cut in half. So here's the active side of Zigzag, which is on its western side, and there's some crevassing in there, and there's a bit of a convex terminus. But the other half of Zigzag is on the other side of this pile of debris here, and there's my sun for scale, and it is just stagnant ice. So it's thinned down enough. This is what ice looks like after it ceases to flow. It just starts to build up debris and dirt, and it's just melting in place. So Zigzag is not healthy, and it's lost. Half of its area is now no longer moving, but at least it is, portions of it still are an active glacier. Moving around to the northwest side now, we've already looked at Sandy and Reed Glacier. We can go to Gleason here, and it's dead. This here is what's left of Gleason, this smearing of ice here on the bedrock there, with Sandy Glacier being over here, showing all those crevasses and its active movement. And on to the north side now, we come to Ladd Glacier, and this one threw us for a little bit of loop. Ladd Glacier, as mapped and recognized by the U.S. government, is gone. And so this is a topographic map of the northwest side of Hood, and this is a satellite image from October 10th. This yellow area is showing the outline of Gleason, what's left of that's smearing, and this yellow is what's showing what's left of Ladd. Now what happened though is that there was a fair amount of rockfall on Ladd that hid ice, and there was a much higher portion of Ladd up here, up towards the summit of Hood, that is not considered part of Ladd Glacier sensu stricto, but is actually part of Ladd if you're just to consider it as a glacier, as not as a geography thing, but as a physicist or a glaciologist would consider it. So this ice body up here is still there, but that is not considered technically part of Ladd Glacier. So Ladd proper is gone. This part that was part of LAD, but never was recognized as part of LAD, is called, we're calling it South LAD Glacier, and that is still an active glacier. And then just to the east here is Coe Glacier, which we showed a photo of before. It's still very much an active glacier. So zooming out now, here is Mount Hood on the USGS topographic map, and then here is that satellite image from October 10th. I'm just showing you here the various amounts of active ice here of Elliott and Coe, but then also we did not show you photos of Newton-Clark Glacier here on the east side of Mount Hood, and that is still an active ice mass. And here's October 10th, and you can see you can barely find those snow patches from where Palmer Palmer Glacier was, doesn't even show up. So coming back to this official list here on Mount Hood, we can cross off Palmer, Ladd, and Gleason. We go to our unofficial though, we have to add back in South Ladd. So there still is an unofficially named glacier that is should be added to that list. So 70 years ago, Oregon had 36 named glaciers, and of that, 26 remain today. So we've lost 10 of our named glaciers. However, we really had at least 57 glaciers 70 years ago, and of that, only 29 remain. So this is climate driven, and we can just show this by some simple calculations. So nearly 50% of Oregon glaciers are gone. So technically about 49% with a rounding up to 50. It's 49.6, I think. Since 1990, that summer mean annual temperature, which is at 0 degrees isotherm, the elevation of freezing where the equilibrium line is, has warmed by about 3 degrees Fahrenheit annual temperature. So that would raise that 32 degree Fahrenheit elevation in the atmosphere by 1,000 to 1,200 feet. Now, looking at the glaciers that died off in the Cascades, they indicate that at least 800 feet of equilibrium line altitude, or that 32 degree Fahrenheit or 0 degrees C elevation in the atmosphere, would have to have risen by 800 feet at least. And the same is true with the Wallowas. It had to risen by at least 200 feet to kill the glaciers in the Wallowas. And we already can reconstruct in the last 30 years 1,000 feet of change. And so that already, just a simple warming from the 1990 to present, was sufficient to kill the glaciers that we have identified as dead. So this is just an example here of showing you what we recognize when we look at a topographic map as the extent of ice here, let's say South Sister. And this is what South Sister actually looks like these days on October 10th, showing this loss of ice. And so I'll hand it back now to Aaron here for the end of this talk here.
Yeah, so following up on that, we want to talk about the future of Oregon's glaciers and what we can do and what you can do. So one thing that we can, start to think about is what the climate is going to look like over the next several decades through the end of this century. 5 or 6 years ago, the International Panel of Climate Change released these models showing what our temperature increase could look like with different types of carbon emission scenarios. So that blue line is kind of showing a good scenario. That is the increase in temperature up to 2100. That would result in about an increase of 6 degrees Fahrenheit by 2100. That's one of our best case scenarios. So that occurs if we can start reducing carbon emissions and even have carbon emissions lower than they are now by 2050 or so. If we do nothing, if the carbon emissions just run away and get away from us and the world does nothing, we may see an increase of 10 to 11 degrees Fahrenheit by 2100. So there's a big difference in taking action and doing something and not doing something. And we're studying glaciers, but really this is about climate change. So if you think about these two different scenarios of what we could see in temperature increase by the end of the century, it starts to hit home. What we want to do is to keep monitoring glaciers and how glaciers are changing with a changing climate. So Honors and I want to conduct field work every year going here on out. We want to get a better handle on the area, the surface area of the ice that's remaining in Oregon. We want to make other measurements too, glacier length and eventually would like to do some work with glacier ice thickness, but surface area is something that we can readily tackle. We also want to look back in history and get a better idea of what glaciers were like back to the 1850s and how they've changed to the present. And we also want to start what we call mass balance measurements. So this is where we actually measure the incoming snow throughout the winter and the glacier melt throughout the summer. We would do this by going to predetermined locations at the same date every year in around April, and we go to the glaciers and we dig into the snow and measure how much snow is on top of the ice. Then in the late summer to early fall, before the snow starts coming down, we can go and look at the ice. And to do this, we need to put some kind of stakes into the ice. So we would physically drill into the ice and put these stakes where we can measure glacier loss. And remember, glaciers hang in this balance of incoming snow and summer melt. So this is something we want to do. That's an important part of a long-term monitoring program. And people are doing this in a few places in the United States, and it's certainly done around the world on other glaciers too. So by doing this, we can really get a handle on how much glaciers are receding or how much decrease in snowpack we're getting at the end of the winter. Just for scale, you know, this is a picture of the Collier Glacier on the left. It's a map, so we would have a transect of these locations where we dig and measure the snow at the end of the winter, and also measure the ice melt along these stakes in the early fall or late summer. And there's a picture of someone there on the right with one of the stakes poking out of the snow. So we can use that to measure change in ice thickness. By doing this and building up a long-term data set, we can combine that with climate projections and try to determine the future viability of Oregon's glaciers. And that's important for us because that's the water resource, and people in Oregon are concerned with water for a variety of reasons. So we want to get that information and be able to, in a sense, project what this water resource will do through the end of the century. So what you can do is to help us do this work. So we started the Oregon Glaciers Institute this year, and it was largely self-funded, and we want to keep this work going on every year. But we can't do that without funding. So if people think this work is important, we would like to hear about that. You can go and contribute to the Oregon Glaciers Institute on our website. You know, in order for us to do this field work, we have to have means to do it. So that's an important part of what we want to do in the next 5, 10 years, 20 years, 30 years, hopefully until the end of our working life. Then somebody else can take it over. We're also asking people to try to dig through your old photographs. If you have old photographs of glaciers around Oregon, we'd like to see those. And what we're asking is that if you have glacier photos from before 2010, to send those to us with the address that is on our website, Oregon Glaciers, or glaciersins.org. It's down at the bottom of the page. So if you send us those old glacier photos along with some or your best guess on when you took those photos, that can help us a lot to work back and see how working out to gather current photos. So we're exploring options of how we can get either an app or a way that people can readily upload photos that they take in the field directly to us somehow. And we're hoping to have something in place for this coming year. And that would be great if people go out this summer after most of the summer snow has melted and take glacier photos, and you can upload that to us. So stand by, we're working on that. We'll have more information about that as we roll into next year. So that'd be really useful for us to get those old glacier photos and current photos. Also, it's important to contact regional and state government. Let people know that you think it's important to monitor glaciers in Oregon. You know, the state of Oregon is really interested in water resources. They have people studying the hydrology of Oregon and monitoring what our water is like, but they've largely looked over the water that's locked up in the frozen form, the glaciers. So I think we all think at the Oregon Glaciers Institute, we think it's important to monitor the glaciers. We ask that you let your state legislators and representatives know that you think it's important to monitor glaciers also. And remember, we are studying the glaciers, but this really loops back to climate change. The glaciers are changing because of a changing climate. If we want glaciers to stick around to the end of the century and beyond, we need to act now. So that's not only a state thing, a United States thing, that's a worldwide thing. It's going to be hard to get the whole world on board with that, but one thing you can do and everybody can do is reduce our carbon emissions, whatever that may be. Maybe it's driving less, maybe it's supporting companies who've pledged to reduce their carbon emissions or go carbon neutral, but that's something that we can all do. That's a small step we can all take. And the world is changing and the glaciers are changing, and Anders and I want to keep monitoring the glaciers just to see and keep track of the glaciers and this precious resource. So that is all we have for now, and just want to thank everybody for listening.
Right on. Thanks so much, Aaron and Anders, for sharing that information. That's super interesting, and I have a lot of questions. We won't be able to get to all of them tonight, but maybe if you're comfortable hanging on for an additional 10 minutes, we can try and get through at least a few of them. And we've still got over 170 people on the call with us. So let's go ahead and just get to a couple of these. This is one I've been wondering about. As glaciologists monitoring the overall loss of glaciers in Oregon, how do you keep your spirits up, especially considering climate projections for this century?
How do we, Aaron? Enjoy it while it's here, I guess.
Yeah, I think, you know, go ahead, Anders.
I was going to say, people like Greta Thunberg give me hope. So I'd say that. My daughter's 4 and talks about killing polar bears by driving a car. So that gives me hope. So sea ice retreats the same reason our glaciers are retreating in. So I think as the younger people coming up, this won't be a political issue. This is just something we need to deal with, and that's what it should be. Yeah. I don't know.
I guess what gives me hope is that, you know, I love the mountains. I love the mountain environment. It's amazing to be up in the mountains and be on a glacier, to go in a crevasse, to ski on a glacier, to climb on a glacier. It's inspiring to be in that environment. It's also inspiring to know that we still have things we can do. So we can still take action on climate. You know, we've had a rough patch here in the last few years with climate policies, but people around the world are recognizing that climate's changing, the world is changing. We can still do a lot. And when you see kids talking about polar bears and ice and driving cars, it's cool to see that, you know, people get it, people understand it, but we can still do a lot, and these places still exist.
Yeah, we got about a decade left before it's kind of like game over. So this decade is it for making major changes, so we got to do a lot, but we still have a little time left. We should have done more earlier, but we didn't. So now it's time to make up for that.
Luckily, it's still the beginning of this decade, right?
Yeah, it's not giving this talk yet. 2029.
Okay, Frederick asks, have you found other regions of the world with similar characteristics to Oregon mountains, like temperature, elevation, etc.? And if so, are they experiencing similar levels of glacial shrinkage?
No, because I mean, Oregon, this is what's kind of cool. If people like the PCT, they know that Oregon is the easiest spot because it's low elevation. I mean, so we have this low elevation plateau, and then as you hike along, we have these volcanoes sticking up into the high elevation, and they're sampling the upper atmosphere. If it wasn't for those volcanoes, Oregon would be the top peak, and the Cascades would be 6,000 feet, and we would have no glaciers. There are other places where the glaciers are restricted volcanoes, but they're different settings. Like, outside of Mexico City, there's a 14,000 foot volcano, and there used to be a glacier there. It's gone now. And in the tropics, you find that, but they're huge volcanoes, like Kilimanjaro is 20,000 feet. So we have, for a mid-latitude site, we're kind of unique that I can think of. I mean, there might be something as you move like into the volcanoes of Kamchatka or north of Japan into the Russian islands, sorry, not Soviet anymore, islands north of Japan and the Aleutians, and then but we're pretty unique here. Yeah. That said, globally, 9 out of 10 glaciers, 9.5 out of 10 glaciers is retreating globally. So you're hard pressed to find advancing ones, and they're usually weird glaciers that, like in Alaska, are in tidewater, or in which can have their own cycle driven by major changes in heavy snowfall regions that can be somewhat independent of climate. So, yeah.
The one glacier in the northwest that's growing is in the crater of Mount St. Helens.
Yeah, there you go.
It grown since the eruption.
Yeah, that's true. So it is growing back. Yeah. So, and yep.
That's cool. Okay, thanks. Mary asks, do glaciers ever come back to life once they're dead?
Mm-hmm. I mean, the one thing that was giving us hope when we did this field work, it was depressing, but at the same time, some of these are like Thayer's long gone. But some of these ones, if we just turned around and cooled the climate a bit and got a little more snow, that ice is sitting there. It's just got to cool a bit and bring that snow line down, and you can start gaining mass again. So it's not irreversible at this point. What do you think, Aaron?
I think, here in the Pacific Northwest, we get a lot of precipitation. Our storms come off the Pacific, and we get a lot of precipitation. So if we can keep things from getting warmer, and, even if for some reason or another, if the climate cools a little bit, these glaciers will come back.
Yeah.
We've got another question here. Are glaciers important for contributing to keeping summer temperatures lower? Or is there a relationship between glaciers and wildfires?
Yeah. Aaron was hinting at this with the cool streams in those forests. If there's not the glacier feeding it, you're just going to the streams will be warmer. So just like was helping the salmon, that cool stream cools the region around the burning fire. So it reduces locally to a little bit regionally the impact of fire and the severity of fire. So they do cool locally the forest. Yeah. Right.
And if the glaciers are gone and you lose those mountain streams, the forests don't have that water, so it's just a drier environment. But if we can keep the water going, there's some water around there, and certainly as snowpack decreases, the forests will also get drier throughout the summer.
And the glaciers and the snowpack are responding to the same thing.
Yeah. Larry asks, how deep is the rock cover on Ruspin? Yeah. And what's your estimate for the number of glaciers that are hidden until discovered by a personal visit like yours to Ruspin?
We don't know.
We don't know. And I would say that, you know, people have seen the Ruspin Glacier, or what we're calling the Ruspin Glacier. You know, there are a lot of people climbing and exploring on South Sister. It's just that it wasn't mapped, or there was no attention given to it. So I'm sure people have seen it, but, you know, these Cascade Mountains from, you know, up and down the Cascade Mountain range see a lot of people climbing and exploring. So there's probably not a lot that's undiscovered, but maybe just not have the attention like some of the glaciers that weren't mapped in Oregon, like the Crack Glacier that Anders showed a picture of, the old moraines. Like, you know, that was even mapped, it just wasn't named when it was originally there. But
Yeah.
and I don't know if, Anders, if you have an idea of how deep the debris is on the Ruspin, but it was pretty thick in some places.
We didn't go over even to try to measure it because the rock fall on that face was insane. I mean, it's dangerous to get over there onto it. You're gonna get hit. So that's why the debris is there, because it's that volcano is shedding rocks like every day in the afternoon. We saw some pretty big slides occur while we were out there. So it's probably a lot of debris there. And once the debris gets about 10 centimeters thick, it greatly reduces the amount of melt occurring. It really insulates the ice. So that ice there's probably a fair amount of ice underneath that debris, and it could go down to much lower elevations. So it's an armored, insulated, protected glacier hiding on the north side of that mountain. It's probably going to be the last glacier in the Three Sisters region to go.
Nice.
Some of these glaciers, I was just going to say, some of these glaciers that are in these really steep cirques, we'll probably never step foot on in the summer when it's just bare ice, because there was just too much rock fall. I mean, like, for example, when we were looking at the Villard Glacier, it was like just a constant bowling alley of large rocks coming down it. So we'll probably, you know, after the seasonal snow melts, we'll probably never step foot on those glaciers to really look at it close. We just have to look at it from as close as we can.
Yeah.
Wild. Okay, why don't we make this the last question for the evening? This is from Shelly, and I'm gonna add a little bonus question onto it. Shelly asked, how did you choose the name for the newly discovered glacier? And my addition is, can you just tell us a little bit about what it was like to come upon it and what it was like to find it?
The name is a joke to my kids. So they're Ruby and Aspen, and I was trying to figure out a way to yell for them without having to say two names, and so I combined them into Ruspin. So we're like, I'll just call it a glacier after this made-up name for my kids. So that's where it came from, and short of anything better to call it, it was pretty funny. We thought. I don't know, Aaron, what do you think? I mean, it was cool. Like, you don't get to discover something new like that much anymore, at least in lower 48. Up in Alaska, it's easy to find a glacier nobody ever knew was there. There's thousands of glaciers there, but in lower 48, it's kind of special.
Yeah, it was kind of cool. When we walked up there, we were looking at the GPS apps on our phones and looking at the map where we were and looking up, and we're like, there's ice there, but there's nothing on the map. And we kept looking at our phone and looking up at the ice, and so it was cool. But I'm sure people have gone by there for decades, but it just hasn't really got any attention.
Yeah. It's pretty neat. So yeah.
Wonderful. Well, thanks to you both so much for taking the time to come and speak with everybody tonight. I am really excited to see what the future of the Oregon Glaciers Institute holds. And for folks who are watching, I've dropped the link for their website in the chat box a couple times, and we'll also send it out tomorrow with a recording. So yeah, thanks again for your time. We really appreciate it, and hope everyone has a wonderful night.
Thank you very much.
Thanks, everybody. Thanks, Jamie.
Bye.
Yeah, you bet. Good night.
Bye.